I've received this GSM module. So this is the SIM800. Now, I made a video a few weeks ago about the SIM900. So this is a kind of smaller size board that nevertheless has similar functionality. So you can send and receive SMS with this. It takes the mini SIM, is it called, or micro SIM? I'm not sure, but not the full size one. You know, the SIMs normally come in a form where you can kind of break it off into 3 different sizes now. So this is kind of not the smallest, but not the biggest either. And you can see from the markings on it, as well as the serial interface, there's also on this side it's got markings for, let's see, turn it around the right way. Yes, it says the bottom 2 pins say speaker, and then the next 2 up say mic. So you can actually connect up a mic and speaker to this and use it as an actual phone. I'm not going to do that. I'm just going to test the SMS functionality as I did with the SIM900. So the procedure is fairly similar. The AT commands often vary between different types of SIM modules, so I'm not expecting the SIM800 to have exactly the same commands for sending and receiving SMS, but we'll just have to find the manual online, download it and have a look. Now with this particular one, this wasn't very expensive. I think it was about £5 including shipping. So this comes with a tiny coiled aerial here, which you can solder in on this, I think it's that one, on this top pin here. I think I will use, I've got a patch antenna which is probably got more gain, so the patch antenna fits into this little IPEX interface up at the top. So I'm gonna try that first. I might try the coiled antenna later, but the room here where I'm testing is a bit of a Faraday cage, so we get a bit of attenuation, and the mobile phone's not always so good here out the back of the house. So yeah, we've got the coiled aerial, we've got some pin headers that we can solder on so that we can plug things into it, and I'll get my SIM card that I used in the earlier video, which is from 1P Mobile. I'll plug that in there, and then we can experiment with it. So I'll plug it in similar to what I did before. So I have this USB interface, USB to serial, so I'll connect this up, and I might have to find some more cables because these are all they're all male pin headers, but we'll connect it up, and then we can connect this into the computer, and we can send commands directly into the SIM800. Now, one thing that's worth pointing out right away is that the board I tested last time runs off 5 volts because it's a kind of standard Arduino add-on, but some of these cheaper modules, they're designed to work directly off a lithium battery, so they will work from 3.3 volts up to 4.2 volts, which is a typical sort of voltage that you'll find from a lithium battery. If you try and run these off 5 volts, I think they get damaged fairly quickly, and I'm sure that I've burned out one of these before. Well, I think it might have been the M590 rather than the SIM800, but I'm sure I burned out one before, and it can be quite mysterious because the board still responds to commands but just doesn't do anything, and it won't connect to the network. So let me solder on some pin headers. I'll find the appropriate cables, and then we'll start messing with the board. So I have some pin headers soldered on now, and the patch antennas plugged in. I've got the micro SIM plugged in here, so that goes in, contacts up like that, there is actually a little, don't know if you can see that, but there's like a little diagram here which kind of shows you where the cutout on the SIM should be. And I've decided to use this this 3.7 volt lithium ion battery. So this is one of these flat batteries that I think I got this one out of a laptop battery. Often when you crack open the plastic laptop batteries, you find several of these type batteries inside. So we've got the power pin, which is the top one here. Ground is the bottom, and then I've got my two connectors, receive and transmit, for the serial interface. So we'll connect up the power. Sorry, it's a bit of a mess of wires here, isn't it? So we get a rapid flashing, which means it's connecting, not connected to a network, I think. Well, let's switch to a slow flash. Oh no, it's gone back to fast flash again. I think it's meant to flash slowly, like the SIM800. It's meant to flash slowly when it's connected to a network. So at the moment it looks like this is connecting and then disconnecting again, because it stops flashing rapidly and then it starts again. So let's connect it up to the computer and we'll run putty and see what's going on the serial interface. So in putty here, let me type AT. Right, so it's responding. Now it says SMS ready. I'm not getting echo of characters. Let me switch the echo on. ATE1, I think it is. That's better. Now you see it is actually resetting, because sometimes when I type things in it's ignoring me. Actually, it's ignoring me quite a lot. Okay, it seems to be stuck in a loop of just resetting itself. So let me pop the SIM out. See if we can put the echo on. So this message seems to be because the SIM is popped out, so I'll put it back in again. But if we do ATI, we should, yeah, so we can see that it's a SIM800 and that's the version of firmware on the board, which I understand can be upgraded so you can reflash it. 80 plus cops. Let's see if it's connected. Not sure that's good news. Right, so if I put in 80 plus C reg, so this is meant to tell me whether we're registered or not, and with the SIM800 we actually had the name of the operator, but there's nothing here. And actually I can see, the module's continuing to flash rapidly, so I don't think it's properly registered at the moment. Now, one hint I've seen online is this command here, C band equals all band. So let's try that. I'll write it to the board, so that becomes the default. Right, so now it's stopped saying SMS ready and so on, so it's like it's not even locking on at all. It should show all the possible modes. And the current mode is alright. It doesn't seem to have made it any better, so I'm going to look on the internet for more hints. Right, a hint I've seen in a couple of places is this, to add a big capacitor across the power rail, so as close as you can to the module itself. So I dug out a 1000 microfarad capacitor from my box of capacitors, and I've soldered that on. So we'll try this. The theory behind it is that when this module tries to lock onto the network, it takes a sudden surge of current, and perhaps these wires are not thick enough to supply the right amount of current, and therefore the module resets itself. But let's power this on again and see how we go. So it's blinking fast again. I wonder if it's going to lock on this time. Oh, it's gone slow now. No, it's gone back fast. Does look very similar, cycling between the fast blink and the slow blink. I just look at the voltage coming from my battery here. So it's reading 3.7, which should be about right. I don't know if the orientation of the antenna is going to make any difference. Right, so after a bit of fiddling about, it's actually locked on now. So you can see the module itself is slow flashing. So what I did there, I've swapped the lithium battery and I've put this on my bench power supply set to 3.7 volts. With no current limit, and the other thing I did was I reseated the aerial connection there because it seemed to be a bit loose, and yeah, so it's now connected. and I'll show you now what's happening on the computer. So if I use this AT plus cops, so it's returning the name of one of our local networks here, T-Mobile. I was expecting it to say 1P like it did when I tried this particular SIM in a different module, but I guess 1P Mobile may be using T-Mobile's network. The other thing we can do is we can actually list out all of the networks it can see. So if we say cops equals question mark, it has a listen around, and then it'll return all the networks it can see, which in this case is T-Mobile, which we know already, O2 and Vodafone. What else can we do? We can look at the link quality, can't we? So that's so 9 expresses the signal strength, and the 0 is the bit error rate. So 0 is a good bit error rate. So we're actually connected now, so we could do a bit of sending and receiving of texts. So we could start by receiving a text. So first of all, I want to set the module so that it's receiving SMS in text format rather than in what they call PDU format, which is like binary coding. So I'm going to do AT plus CMGF equals 1, and also look at the character set that's selected. So that's AT plus CSCS question mark, and that says IRA, which is the default, and I'm not really sure what the effect of that is, but we'll experiment with it and see what happens. So I'm going to use the same mechanism for testing that I did the last time with the SIM800 module, which is to use a cloud service for sending texts. And if you want to understand what I'm doing there, then I'll put a link here to that previous video, and you can see what I'm doing, and also follow the links to my GitHub where all the code has been put. Okay, so I'll run my send SMS script. And this is much like we had with the SIM800. So we get this CMTI indication. SM means that the incoming text has been stored in the SIM module, and this index 1 is what we need to read it back. So we'll do AT plus CMGR equals 1, and that returns all of the details of the SMS that we just received. So it's rec unread because this is the first time that we've seen this particular message number 1, and so there's the sender's number, the time and date that the text arrives, and of course the actual text of the message itself. And like the SIM800, we should be able to list all messages that have been received. So we'll say all like that, and now you see there's only one message actually in the list. This would list out all of the SMSs on the SIM. What have I done there? CMGL equals all. Okay, so we've got message number. Now it's marked rec red because we've seen this message before, so this allows you to tell the difference between messages that have been received for the first time and ones that you've already dealt with, and all the other details that we got from the CMGR command. Now, while I was looking around for examples with the SIM800, there's another mechanism that we can use that I didn't use before with the SIM900, but let's try that now. What we can do is, instead of getting the indication and then doing CMGR, we can get it to actually send the whole message in the initial indication. So let's try that. So we do AT plus CNMI, and we set mode 2 for the SMS, and then these final 3 parameters are to do with cell broadcast, which we're not really interested in here. So I'll set that, and now we'll send the text once again. And there we go. Now we get a different procedure. So we get the CMT indication instead of CMTI. But you see all the other information is the same. So we've got the sender ID, we've got the date time, and then the actual text of the message. So that's quite nice, and it allows for simpler programming than the method that I used with the SIM900. So I might work up an example for that. A Python example for that. Alright, so that's pretty straightforward. Now we could do the sending a text demo. Well, just before I do that, let me clear the... We've still got the first message loaded. So like with the SIM900, we can delete messages on the SIM card with AT plus CMGD equals 1. So that should delete it from the SIM memory. Yeah. So I'm confident that the code example that I wrote before for the SIM800 will also, for the SIM900 rather, will also work with the SIM800. Right, so let's try sending a text, and this is the AT plus CMGS. And I'll use here my Nexmo number. So I've allocated a mobile phone number on the cloud service Nexmo, well, also called Vonage. So they've been transitioning from the name Nexmo to Vonage. So I bought this 7447 number, so a normal mobile phone number, but instead of being associated with a SIM, you can connect it to a cloud service and you can send and receive texts under program control through their API. So AT plus CMGS and the number, and if I do enter, so we get this greater than, which is a prompt, and it's wanting me to send a message. So so I'll just send a message, and you can keep going, you can put multiple lines if you want, but I'm just going to terminate that message, so I'll do Control Z, which is the terminator, and hit enter. And the plus CMGS is the confirmation that the text has been correctly sent. So now if I pop up my Vonage account, we'll be able to see whether that message has successfully been received. Search by number, that's my Nexmo number, and there we go. So there's the message received, so time and date. So this is my 1P mobile number, so the number associated with that SIM card from 1P mobile, and my Nexmo number is the destination, and here you see the text of the message. Oh, that's interesting. The \n means it's put a line feed in, so because I didn't do Control Z at the end but I hit enter, it's put a line feed in. Okay, so you can see that basically with this module SIM800 I can both send and receive texts, which is where I wanted to get to. Yeah, so that's pretty much all I wanted to say in this particular video. I just wanted to get this less expensive SIM800 module working, and it certainly does seem to be working very well. I'm quite pleased with that. I've just received another module, which is something called the M590. So this was quite cheap. This was about four or five UK pounds, which is not bad. This one is even cheaper. This is a £2 module, and you can see this comes as something of a kit that has to be assembled. So in a future video I'm going to use the M590 and try and get to the same place with the the bargain price SIM module, GSM module. Okay, thanks very much for watching, and I'll see you in the next video.